Hey guys, welcome once again to Physics Tutoring from Odds. Now, this time we're going to go over something called SI units, which stands for Standard International. So, as you can probably guess from the name itself, Standard International means it's standard across the world. Okay? Which means the entire world uses these units. That's why they're so efficient to communicate with. Because if somebody around the world uses pounds and someone else uses kgs, and suppose they're working on the same project, if they use different units, then how exactly would their units correspond? Wouldn't it be hard for them to work together or make progress on something when both of them are divided on what to use, really? That's why we have something called SI units. These are the standard units that will be used internationally or in a physics classroom. These are they're different from commonplace units. So in the US, we still use pounds, even though these pounds is in the SI unit. But still, SI units take prominence in scientific matters or anything regarding science or labs or experiments. SI units take place, even during classes. That's when SI units take place. So this is a fun fact. The Mars orbiter was lost in 1999 because, some team mixed up pounds with newtons, which is, unfortunate, but you can see how these can be $1 million mistakes, right? When you're starting your physics journey, something you want to remember is you want to keep your SI units with you all the time. You want to make sure you know them by heart because, it can save you a lot of money. There's 7 base units, and these are really the main ones you need to know, I would say. The first 5, okay? Length, which is measured in meters, denoted as lowercase m. Mass, measured in kilogram, denoted as kg. Time, measured in second, denoted as s. Electric current, measured in ampere, denoted as A. Capital A here. Temperature, measured in Kelvin, denoted as K. So this is one of the trickier ones, right? Because usually we use Celsius or Fahrenheit. But Kelvin is specifically used for science because it's the point at which water freezes or boils. That's why it's more useful as a reference point than Celsius or Fahrenheit. Now, another thing you want to keep in mind is all of these units look, base, right? M, and then you could have kilometer or centimeter. But meter is the base unit. However, for mass, gram would be the base unit. But then kg is the standard international unit. Why is that? Because gram is very small, right? The average person weighs around 50 kgs. How would you denote that as grams? You would say 50,000 grams, which is way too much to measure. And the decimal points and the zeros get out of place quickly. That's why we use kgs, because things on Earth tend to weigh heavier. So that's why we use kgs as a unit of mass. Not a unit of weight, which I'll explain the difference between in a bit. But mass and weight are different, okay? Mass is denoted by kilogram. Weight is something else that we'll learn later on. Yes, you want to make sure you have all these 5 by hearted. Okay. Now, there are standard units and there's derived units. What are derived units? The standard units are the units that are base, right? You can't really get them from anywhere. We just made those up and we said, okay, these represent these values. But derived units, they represent values that are a combination of standard units. See how a Newton, which depicts force, is a combination of kilogram for weight, or mass, meter for length, and second for time. A Newton is a combination of all of these. So we use this Newton, but it isn't a quantity by itself. It's a quantity made up of all these 3 units, right? That's why they're called derived units. You use standard units to make them. Now, a joule is a Newton times a meter. So kilogram times meter over second squared. If you multiply that by one more meter, it makes sense how you're going to get kilogram meter squared over second squared. Watt is a joule per second. So if you divide this by one more second, the second squared times second in the denominator becomes second cubed, which makes sense. And then pascals, kilogram meter times second squared. So that's a Newton divided by meter squared. Okay, charge is a coulomb, which doesn't use newtons. It's one of the few derived units that doesn't use newtons as a base. It uses amperes times seconds, which, if you remember, was for electric current, and seconds was for time. Okay, and then hertz, or frequency, is measured using 1 over second, which is just a hertz. So there's no really combination here. It's just you take one unit and you do 1 over that unit. So it's a bit different from the regular unit itself. So I would say these are the main ones you want to focus on. Force, energy, power, charge, and frequency. These come up the most often. Pressure, pascals, they do come up often, but not in the course that I'm going to be going over. So let's go over some practice questions together, right? How many base units does SI define? Well, I said we only use 5 units, but we actually use 7 units, right? The 7 units are the basis for everything across, but 5 units are the most commonly used. So yeah, go ahead and pause the video and try to give yourself some time to figure out all of these questions. We'll be going over in-depth questions later when I send out PDFs to the OTS website, but for right now, just take a look at these tiny questions and see how you do. All right, now let's go over them. Give the SI base unit for mass. Well, I told you that gram is a bit deceiving, right? It's not gram, it's kilogram, because gram is too less to weigh something. Most units have more mass. That's why they're called kilograms. The average person is 50 kilograms, and then you'd have to write that as 50,000 grams, right? Which would take a lot of space and a lot of zeros. So we could just write it as 50 kilograms, right? Takes less space. Which quantity is measured in Kelvin? We know that to be temperature. And is the Newton a base or derived unit? It's a derived unit, because if you memorize all the base units, then any unit that's not a part of the base units is a derived unit. Okay, let me write that down. Units not part of base units are always derived units. That's why it makes a lot of sense and it helps you a lot if you memorize the base units, because then you can know which one's a derived unit. Okay, so derived unit is Newton, right? It's derived, and we know that's a kilogram times meter per second squared. If you're having trouble with this number and you're wondering why, I'll be going over it in the few coming sessions when I go over F equals ma. But for right now, I can just show you that m is measured in kilograms and acceleration is measured in meter per second squared. So the ending unit, or the unit for a Newton, would be kilogram times meter over second squared. And write the symbol for the unit of electric current. Now, most of the units are lowercase, right? But you want to remember that the one for electric current is ampere, which is capital A. So if you look here, you can see this is capital A. Most of them are lowercase, but some of them are capital. Okay? If you did good on that, good job. We'll be going over some more in-depth questions later. And then we'll go over how to convert between units. Okay, so if you wanted to see what we'll be going over SI units, and then later on we'll go over Sultan graphing, conversion between units, trend lines, packing fractions, and then we'll review all of it in a more encompassing video. Okay, here are your answers. All right, good job, guys. Keep going.